Alright, today we're going to talk about quadrantal angles, meaning angles that end up on the x or the y axis. In order to figure out what to do with them, we're going to work from our strength. We're going to talk about the patterns we can find when we find angles that terminate on points in quadrants. So if we had an angle that ended on the point -8, 6, we know that it would start here in standard position, and -8, +6 would put us somewhere over here in quadrant 2 where it would finish. We know that when it's bigger than 90 degrees, we always use the reference angle, the angle between where we stop and the x-axis we're closest to. And we connect our point to the x-axis we're closest to create a 90-degree angle, and then we can use our right triangle to find our information. We've found the measure of the angle, we've found the measure of the missing side, we've set up the 6 ratios, we've done all those things from this location. What we've always done is put the 2 sides of the right triangle on that we know. -8, +6, and because our reference angle is here, this was our opposite and this was our adjacent. Okay, it didn't matter what quadrant we were in. We did it the same way. We started at 0, 0 and the positive x-axis. -10, -4 places us in quadrant 3. Our reference angle is between where we stop and our x-axis we're closest to. We connect to make a right triangle, and we place on our units. We went 10 left, so -10. We went 4 down, so -4. And because our angle is here, again, this is the opposite, and this is the adjacent. Now, notice what develops here. In both of these pictures, the opposite was the y coordinate. And in both of these triangles, in both quadrants, the adjacent was the x coordinate. And what some keen observer noticed was that no matter where they were, the adjacent was always the x and the opposite was always the y. And so instead of thinking of sine as opposite over a hypotenuse, they said, well, it's just the y over the hypotenuse. Instead of tangent being cosine being adjacent over hypotenuse, it's just x over hypotenuse. And instead of tangent being opposite over adjacent, well, that's just y over x. And so we had those rules called the general rules for ratios. Now, they don't use hypotenuse when they write these in the book. They use r. R stands for the distance the point is from 0. If the point is in a quadrant, then you have to use a squared plus b squared equals c squared to get it. And if it's on an x or y axis, we'll talk about that in a minute. Since it is a distance, it's always a positive value. Distance formula in geometry always gave us a positive value. Here we are always having a positive value. I'm going to attempt to fit on these 2 examples here, and I'll skip over that one. Alrighty, so the problems we will have to use these general ratios for are ones like these. These are called the quadrantal angles because they land on the dividing lines between the quadrants. If you graphed 0, 5, we would know, hey, we're going to start here. If our angle stops at the point 0, 5, that's 0 for x, 5 for y. That's just straight up in the air 5. When I connect the angle, I realize, oh, it's just a 90-degree angle. Okay, how do I write the sine, the cosine, and the tangent for that? Because if I drop a straight line down, I didn't make a triangle, I just made the angle again. Okay, so this is when you have to use your ratios. We already know our x is 0 and our y is 5. If r is our distance the point is from 0, what's our r going to be if we're at 0, 5? How many spaces away from 0 are we? Since it's a vertical line, you can just count down. Oh, we're 5 spaces away from 0. Okay? So then we can quickly write the sine is y over r, so 5 over 5. But that simplifies to 1. The cosine, which would be x over r, so 0 over 5. 0 divided by anything equals 0. And the tangent, which would be y over x, so 5 over 0. Division by 0 is not allowed to happen. It's written out as undefined. When you take your quiz on Schoology, either write out the word undefined or write undef for the abbreviation for it. Okay? Making the 3 reciprocals. Remember, a reciprocal of sine is a cosecant. Well, that would still be 5 over 5, so that would still be 1. Secant is the reciprocal of cosine, so that's 5 over 0, which now is undefined. And what used to not work, tangent is now cotangent, so that's now 0 over 5, which simplifies to 0. Okay, one more time. If we start here, negative 7, 0. If our x is negative 7 and our y is 0, we're going to be over here on the left. Oh, well, that's just a 180-degree angle, but that wasn't the question. We're finding the 6 trigonometric values. So we need to know what r is. How far away from 0 is this point? Well, we went 7 spaces left to get there, so it is 7 spaces away. Remember, don't put the negative. It is always positive because it's the number of spaces from 0. Okay? And then set them up. Sine, cosine, tangent. Sine is y over r, so 0 over 7, which simplifies to 0. Cosine is x over r, so negative 7 over 7, so negative 1. And y over x for tangent, so 0 over negative 7 equals 0. So where the 1s are, where the 0s are, where the undefines are, if the 1 is positive or negative, vary from problem to problem. But there will always be 2 zeros, 2 1s, and 2 undefines when you set up all 6 ratios. Alright, so sine turns to cosecant. So now it's 7 over 0, so undefined. Cosine turns to secant, 7 over negative 7, so negative 1 again. And cotangent is negative 7 over 0, so now undefined. Okay, always please simplify your answers to simplified terms, 1s, 0s, and undefines, and ask questions if you need help.